Hello, today I would like to show this quite interesting tiny battery tester. This is something that I pick up locally for a video. I was pretty sure that it's going to be terrible, but it ended up to pass my expectation, and it ended up to be extremely good product that I can basically recommend. And it have a very good feature that I'm going to discuss with you. First, let's take a visual inspection. So we've got a LCD screen that will allow us to read the voltage. It's called the battery tester, but I'm pretty sure it is a generic name and you can buy that in the AliExpress under different name. And we've got a cheat sheet telling us what kind of voltage represent a brand new battery that is full, that is a medium charge, and that is completely empty, the layer. From that list we know that we can test a recharge-able batteries that got 1.2 volt nominal, regular 1.5 volt batteries, 3 volt and 9 volt. So a pretty common set. It looks like this, and here we've got some technical markings, just if you would be interested. On the back we've got a 2 AA batteries, and this is how it looks like. We've got a push button to enable the device, and as you can see we read 0 volts. And if you take a look at a regular meter that I'm using right now, you do not have any leads, and that's because you've got that clip that allow you to put different batteries over there, over here, or you can just touch to those contacts. You might say that this is a first world problem, but I pay for this like €2, which is absolutely great, and I notice that I'm constantly going for that device and I don't want to unfold those wires. I keep this next to my battery tray and I'm using it for a quick check, and it is really nice. What makes this device special and better than my benchtop meter and this tiny meter, this device is testing batteries under load, so it's providing a current sink, most likely some sort of resistor, or that might be a digitally controlled element like an electronic load, and that way you are getting much real case scenario, because battery can read open voltage that is going to be correct, but after applying even tiny amount of resistance across that will create a current path, the voltage will sag down and it stop working. I've got that multiple times with cheap batteries, that if you test that on bench it read okay, you put it into device, it starts to run and it displays the battery is empty. So testing batteries under load is a good thing, and this device have that capability and we are going to test it. Let's start our measurement from 9 volt battery. You are opening that clip, you close it down, you press the button and you just read the value. So as you can see we've got 1.6 volt and the voltage is dropping. That's because the built-in resistor is discharging the battery. So you've got the reading under load. 9 volt batteries, we read much below the empty value, so that battery go into the recycle. Here I've got a couple batteries that I pull out from motherboards, and you can also test them. So I'm pressing the button and I'm touching it, and this is true that battery is completely dead. This is a completely dead battery from an old motherboard, and it read 0 volts. I've got couple more. We can test that one. And this one, if we take a look at the 3 volt, we are below 2.6 volt, which make this battery dead and it go into the recycle. And the last one, we go like this, and it read a 0 volt. To test like a double A's, we go here and into that slot, and we've got 1.3 volt, which is for rechargeable, a full battery, and that is true. We can grab a different one. Also looks okay. Keep in mind that this measurement is being done under load, and we are going to do that in second. R14, it also nicely fit into that spot, and as you can see, 1.5 volt over 1.4 volt, it is a fully charged battery. R20, extremely beefy battery, but it still go into the place, and it is a fully charged battery. That one is fully charged, and as you can see, I've got a wrong polarity, which is being nicely displayed on the screen. So it is good one, non-rechargeable, and as you can see, we've got a nice measurement and AAA rechargeable. We go like this, and as you can see, it is fully charged. Let's do our first scientific experiment. So we've got that used battery. I'm going to attach it to the pins, and if we take a look, that battery is bad. That battery should be thrown away. But if I'm going to measure it with my benchtop meter, I'm reading 2.7 volt, which is looking quite okay, and as you can see, it's rising. So the question you might ask, does this meter is uncalibrated, and that's why the big difference? But it's not, and I'm going to show you that in second. I will put my battery like this. We are reading 2.4 volts. I'm going to touch those two pins, and you observe the benchtop meter, see what's going to happen. And I'm asking you, do you still see that big difference? Are those two meters are showing a different value, or they are close? Because for me, they are really close. And as soon as I remove the load from the battery, it's going to read a pretty high value. So as you can see, you can be fooled by measuring just the open circuit voltage. You put that into your device and it suddenly stop working or reporting a low battery. This is why tests under load make a lot of difference. Voltage is building up. I'm grabbing the meter, I'm touching it, and the voltage is sagging. So as you can see, they are both showing a very accurate reading, and it is a good measurement. I created here a very small lab test setup. We've got my power supply that is providing 1.5 volt. It is in line via that probe with my benchtop meter that is set up to milliamp, and we are going to read the milliamp value. One of the wires is directly attached to the tester, and it's closing circuit via that probe. We are going to start from the terminals that are dedicated for 1.5 volt battery. I'm just going to touch it, and you can see that we are pulling current that is equal to 70.5 milliamp. This is what you are going to pull from battery while testing. You are loading your battery. Let's take a look at the front terminal and see what kind of current are we sinking. And I'm reading value of 0.10 milliamp. I will change the range to the microamp. And we are reading 100 microamp. Now we are going to see, is it just resistor? I'm going to double the voltage into 3 volt. This is what it is rated for checking the computer motherboard size of coin batteries. We've got a 3 volt, we double our voltage, so the current should be also double, and this is exactly what we see. So inside there will be just a resistor. Since that port is also being used on a 9 volt battery, let's see what kind of current are we sinking, and it is around a 600 microamp, and this is equal to 0.6 milliamp, so a very tiny load, but you can expect that from a coin size battery. You don't want to drive them too much. So as you can see, this device is very nicely loading our battery and giving us a more accurate reading. The native value are very compared to my benchtop meter, so you do not have to be afraid that this meter is going to be offset. And it's so easy to use, so handy, that I can only recommend it. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.